For our second video in section 3.3, we're going to be looking at two different examples here. For our first one, we need to write and use a system of inequalities to solve a real-life problem. And in this case, it says medicine professionals recommend that patients have a cholesterol level below 200 milligrams per deciliter of blood and a triglyceride level below 150 milligrams per deciliter. Write and graph a system of inequalities that represents the range of cholesterol levels and triglyceride levels for patients. Let C represent the cholesterol levels and T represent the triglyceride levels. Well, looking at our information that was given, we can see then we need our cholesterol to be, well, I should include that part, below 200 milligrams, and that we want our triglyceride to be below 150 milligrams. So if our cholesterol needs to be below 200, and cholesterol is our y-axis here, it looks like, and we're using the variable C, we would say C has to be less than 200. Similarly, triglyceride is our x-axis here, going left and right, and we're using T. We need it to be below 150 milligrams, so we just say T is less than 150. Making a graph for this then, we look at our inequality, C is less than 200, and we can consider that like the line y equals 200. Again, that's just going to be a horizontal line at 200, and we know that it's less than or just less than, not less than or equal to, so we need to put a dashed line going right across. Same thing with our T. T has to be less than 150. So we think of that as like an x equals 150, but because it's less than, not less than or equal to, it's a dashed line going vertically right at 150. Now looking back at our cholesterol inequality, we need it to be less than 200, so we shade everywhere below 200. For our triglycerides, it needs to be less than 150. Less than would mean smaller, or everything to the left, so we'd shade everything over here. Suppose I can fill in more. And we'd notice then that there's only one area right here of patients that are in the quote-unquote healthy zone. So this is where you want your patients to be, somewhere with a triglyceride level between 0 and 150 and cholesterol between 0 and 200. But they can't be exactly 200. That's why we have our dashed lines up here. They can't be exactly 150 for triglycerides. That's why this is a dashed line. But let's say you had a patient who had 100 for their triglyceride and 150 for their cholesterol. So that would put them right here. They would be in the safe zone. That is an okay patient, nice and healthy. For our second example here, we need to find the vertices of a polygonal region. Now what that means is we're going to be graphing out our three inequalities and finding exactly where they all three intersect. So in this case, we're no longer using just two inequalities or two lines. We have three. Then we're going to shade our regions, and there's going to be a spot where all three regions intersect, and it's going to make a shape. Obviously, it's going to be a triangle because we have three lines, so three sides. Then we're going to find the corners of that triangle, and that will be our vertices then. Okay, so the very first thing to do with our inequalities is change them into slope-intercept form. If we look at our first one, we have 2x minus y is greater than or equal to negative 1. If we're trying to move it into a y equals mx plus b form, we need to get rid of that 2x first. That'll leave us with negative y is greater than or equal to negative 2x plus negative 1. Now we have a negative y out here. That's like saying negative 1 times y. So to get y all alone, we need to divide by negative 1. Now remember, dividing by negative 1 means we need to flip this inequality sign. So when we divide everything by negative 1, it becomes positive y is less than or equal to positive 2x plus 1. So that is going to be our slope-intercept form of our first inequality. For the second one, we have x plus y is less than or equal to 4. Well, in that case, all we have to do is subtract x, and we can get y is less than or equal to negative x. So that one is already, it's in slope-intercept form for us. We don't need to multiply or divide anything. For our last one, we have x plus 4y is greater than or equal to 4. So we need to subtract x from both sides. That's going to leave us with 4y is greater than or equal to negative x plus 4. Then we need to divide everything by 4, and that'll leave us with y is greater than or equal to negative 1/4 x plus 1. From here, we just continue on with solving our graphing of system of inequalities, only we're doing it with 3. So we go back and look at our individual inequalities. I'll start with our first one here, and we plot the y-intercept at positive 1. Looking at our slope, we go up 2 over 1, up 2 over 1, and so on. And in the other direction, down 2 over 1, down 2 over 1, and so on. Because it is a less than or equal to, we will have a solid line for this one. And I'm going to shade these really, really light because we've got 3 things to shade here. But because it's less than, I'm going everywhere in this direction. All of this is what should be shaded. Let's look at our second inequality here. We have y is less than or equal to negative x plus 4. Well, same thing. We go to the y-intercept, positive 4. Our slope is negative 1, so it means go down 1 over 1, down 1 over 1, and so on. And that'll even go in the opposite direction. Again, it's less than or equal to that. So we connect it as a solid line because we have the or equal to part. And we're going to shade everywhere, again, below that region. So all of that would be shaded. And already we can see a spot, looks like everywhere in here, that is going to be allowed. This looks like our solution area so far. But as we work through here, we'll find out that that is not the only spot that works. We have to constrict it a little bit more to say that this really is the only spot that works. Some of that spot doesn't work. So we'll have to look at our last inequality, this y is greater than or equal to negative 1/4 x plus 1. Same thing as before. We start out by plotting that y-intercept at positive 1. We need to go down 1 and over 4. Down 1 and over 4. That's going to put us off the chart here. We can continue in the other direction as well. Up 1, left 4, up 1, left 4. And then we just connect the points. Now in this case, it's a greater than or equal to. So we need everywhere that's above all of this. The only shaded region that's going to be above the blue, below the red, and below the green is all of this stuff in here. So this is the only area that will work for our inequality. Now, if you notice, right here, here, and here, and those stars are a little bit behind them, those are the spots where all of our lines intersect. Okay, not all 3 intersect at one spot, but those are the corners of the triangle that those 3 lines kind of enclose. So if you look at each of those spots, those are going to be our vertices. And those are all found at 1, 3, 0, 1, and 4, 0. So those are the solution. Those are the vertices of this triangle that would enclose our solution. In our next unit, we'll see how we can use that to maximize or minimize a function.